Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everybody. Thank you for coming to our presentation. This research was done by Mr. Nugroho Ade and I, Bhaskara Wisnu, but now I will represent this research alone. We are from the Department of Electrical Engineering, Diponegoro University, and the topic of our presentation in this afternoon is design and development of automatic transfer switch system, energy-saving emergency panel. Let's talk about the background of our research. The biggest problem today is massive use of fossil energy sources, which are used for various needs such as electricity. So we need backup from other basic sources such as solar panel source. And then the second problem is grid source from electricity company PLN in Indonesia sometimes has problem such as power outage. In fact, electricity consumers such as hospital need high reliability of electricity. So adding the UPS system in the solar panel system can solve the problem. Because of that problem, we decided to make auto transfer switch system that can switch power source from grid source or solar source automatically or manually. And we designed this system automatically to switch the solar power source from 10 a.m. to 2 p.m. To get better reliability from this system, we adding UPS to the system. In general, the block diagram that we use in this research can be seen on the slide. The solar power source is simulated with 12 volt and 100 ampere hour battery connected to the solar charge controller that can disconnect the battery voltage when the battery voltage drop to a predetermined value, and then can be reconnected when the battery voltage rise to a specific value. The solar charge controller will forward the battery voltage to the 2000 watt inverter in the ICITACEE panel. The grid source or power source from state electricity company, which is a single phase system, 220 volt AC voltage and 50 Hz frequency. And the UPS source of the UPS is simulated with 12 volt and 100 ampere hour battery, which connect to 1000 watt inverter. And for the ICITACEE system circuit consists of timer, contactor, and time delay relay. For the algorithm of the ICITACEE system is first automatically switch to solar source at 10 a.m. to 2 p.m. or we can call the solar auto mode. And second, automatically switch to grid source when solar source is not available in the schedule 10 a.m. to 2 p.m. or we call the grid source. And the third, automatically switch the UPS source when grid source is not available in outset the schedule, or we call the UPS auto mode. And user can switch the solar source manually, we call it solar manual mode. And 5, user can switch the UPS to UPS source manually, we call it UPS manual mode. And manual mode can be switched with pressing on button and pressing off button to turn off. And we adding the emergency button to cut off solar connection if any emergency condition. From that algorithm, we can make the ICITACEE floor chart system. We can see on the left in the slide. And the ladder system we use in the ICITACEE system can be seen in the slide. It appears that the ICITACEE system we use is used 220 volt source. This ICITACEE system consists of grid and UPS circuit. The grid is for state electricity company or PLN in Indonesia. Now we can simulate this system with Fluid Sim software. Okay, this is the Fluid Sim software which we'll use for simulating the ATS system. Normally, we get our power source from the grid, from State Electricity Company, PLN in Indonesia. And when we add the solar system, and the clock show 10 a.m. until 2 p.m. and the switch is auto, timer will be closed, and the source is now from solar source. Now we running in solar auto mode, and when the timer is outside of schedule, it will be open and it's back to grid source. We can turn on manually by changing the solar switch to manual and pressing on button to turn on the solar manual source. And then now we run in solar manual mode, and we can turn off the solar manual mode with pressing off button, and we back in grid source mode. And if the grid power outage happen in the grid, it will be activating the UPS auto to turn on UPS auto mode. It's need 15 seconds to make it active, and we can turn on this UPS to use manual mode by changing the UPS switch to manual and then pressing on button. It's instantly use UPS manual mode. Okay, this is for our implementation of the ATS system. We can see where outside of the panel box there are indicators of solar, grid, and UPS, and then measurement equipment for solar source and grid source, and then two auto manual switch for solar and UPS, and then two manual button for solar and UPS, emergency button, and output. And the inside of the panel box, we can see there is MGB source from solar, grid, and UPS, and solar timer, then solar inverter, UPS inverter, contactor, and time delay relay system, and the last is all MCBs. Okay, let's try this ATS panel. Normally we use the grid source, and when this ATS switch to auto and the timer is turned on, it will be off the grid and turn on the solar source. It takes 15 seconds, and the lights will be on. And when it's turned off, when timer is turned off, it will back to the grid. It takes 10 seconds. The light will be on. We can also turn on the solar source manually. We switch the solar switch to manual and turn on. It's turn off the grid source and will be turn on the solar source. It takes the 15 second. Okay, it's solar source manually, solar manual, and we can turn off the solar manual with push the off button, and it will be back to the grid source. And when the grid source is not available or power outage is happen, it will be off and it's automatically to turn off the UPS source, UPS auto. We can also turn on this UPS with manual, with switch this UPS switch to manual, and then turn on the push the on button to turn on the UPS manual. Yes, it's instantly turn on the UPS manual. And when source from the UPS and the grid is available, power from the grid is available, it will be back to the grid source. Okay, finish. Bye. Okay. Disable is the result of the performance test, where from the table, when the solar source is set to auto, and timer is on, ICITACEE will switch to solar source automatically, and when it's timer off, ICITACEE will return to grid source. This is the same as simulation we did before. So the ICITACEE system has worked according to the algorithm that we have designed. Load tests have also been carried out where using static load. The values of voltage, current, and power, and then Mosby is not much different, as well as when using a load test. The voltage, current, power, and Cosby is not much different. Okay, this is the curve. That's our expectation daily load curve. And when solar power is operated at 10 AM until 2 PM, it will save 70 and 44 watt-hour of 33,753 watt-hour. So it can save 21.17% of total daily power consumption. Okay, thank you. Thanks for your attention in our presentation. See you. Bye.